rational functions. Again, as I said, this is section 2.6. You may want to have your graphing calculator out because we're going to be utilizing those a little bit with this. Now there are some rules here with graphing rational functions. There's actually quite a few steps that we're going to make as we go through it. So I'm going to use example 1 as our starting point here with this. So notice here a rational function, we've got basically a fraction where we've got a polynomial on the top and a polynomial on the bottom. Okay? Our first step on all of these, step number 1, we are going to factor anything that's factorable. So if we look at this one, 2x plus 1 over x plus 1, there's nothing we can factor. So we're ready to kind of go ahead and move forward beyond that point. That's going to be the first thing you always want to do. Okay, the second thing we're going to check is we're going to check and see if in our graph, are there going to be any holes in the graph? Okay, you say, well, how do we determine if it has a hole or not in the graph? And here's what we do. A hole is going to occur, and I'll write this down for us here. This occurs when a factor of the numerator cancels with a factor of the denominator. Okay, so as we look at this first example, the factors on the top and the bottom, there's nothing that cancels. So what that tells us on this one is there are none. There aren't any holes in the graph. Does everybody understand what I mean by a hole in the graph? Just means that there's a space where there's not a point, so it'd be an open circle on the graph. Okay, the third thing we're going to check is we're going to check to see, are there any vertical asymptotes? Now the way that we check for a vertical asymptote is we are going to set the denominator equal to 0. So in this particular one, we're going to set x plus 1 equal to 0. So we learned that there's a vertical asymptote at x equals -1. I'm going to go ahead as we're going through this and we can kind of sketch in what we're learning as we go. So x equals -1. Okay, for step number 4, we're gonna determine, does it have any horizontal asymptotes? Now, for the horizontal asymptotes, we've got 3 kind of special rules that we use to determine on this one. So as we look at our rational function, you know, on the top we got AXN plus and so on. On the bottom, BX, and so on. So I'm using the variables n and m. Might be easy to think about it if we use n for the top, the numerator, the numerator degree, m is the denominator. So here are kind of the 3 scenarios we've got. Number 1, if n is less than m, then the horizontal asymptote is y equals 0, which is basically just the x-axis. The second would be if n is equal to m, then we say that the asymptote is y equals a over b. Now when I'm saying a over b, I'm talking about the leading coefficient. So notice in the problem we have here, would everybody agree that the degrees are the same? They're both 1. So n is equal to m. That's the situation we have in this first example. So we would say that y is equal to 2 over 1. And it's just going to be, yeah. Now the third scenario would be that if n is bigger than m, means the degree of the numerator is bigger than the degree of the denominator, then we say that there is no horizontal asymptote. Now this is the scenario that we have to be careful about, because if n is bigger than m, it's possible for us to have a slant asymptote. Alright, so if we have a slant asymptote, again, that means that n is bigger than m, but it has to be bigger than m by exactly 1. And if that's the case, for us to find the equation, we're going to use long division or synthetic division to find the equation. And we'll get to that here in just a minute. So I'm trying to give you all the rules here as we go through this on this first example. So what we've got so far, let's go back to our graph. We know that one of our horizontal asymptotes is at y equals 2. So we've added that to the picture. Would you say that this one Would we have a slant asymptote on this one? No, we don't, because it's situation number 2, so it's not n is greater than m. So, no slant. Now, once we get to this point, this is where I'm gonna say, let's go ahead and use our graphing calculator. You know, we could spend the time and go ahead and have you plot in some points and find points, but again, since we've got our calculators, we're gonna go ahead and type it in and see what we come up with on our calculator. Hopefully, when you type that in, again, these asymptotes are gonna always be lines where the curve is going to approach, but never really touch the line. So it's gonna look something, and when you type this into your graphing calculator, it's gonna look something to this effect right here. And the upper left part of the dotted lines. And in the bottom right, it's gonna look something to that effect right there. Again, it's very important on some of these ones where we're gonna do, you're gonna find that they have a hole. And there's some of these where the lines will cross over the asymptote in certain spots if we have multiple places. Your graphing calculator is not going to show that. And that's why it's pretty important that we find where the holes are. And it's pretty important, you know, as we're making the graph, that you know that, so that way when you're looking at your graphing calculator, you'll be able to determine that. One thing that's always a good thing is on your graphing calculator is utilize your table. If you need to, when you're identifying points, did everybody get the graph to show up on your calculator? It appears pretty similar to the way I've sketched it there. Everybody good with that? Before we go on to example 2. Any questions? Okay, so let's take a look at example 2 then. Is everybody good on all the rules? Everybody have that written down?
What does the bottom one say?
The bottom one?
Yeah, no slants.
So, if n is bigger than m, in other words.
I just meant like on 5, near.
Yeah, it just says no, there's no slant asymptote. Okay, so let's go ahead, go to example 2. Okay, so here's example 2, we've got f of x equals x minus 4 over x squared plus 4x minus 5. So step 1, we're gonna factor. So you'll notice on this one we can factor the bottom. The top remains x minus 4. And the top becomes x plus 5, x minus 1. You know, I'll just write the rules over here again to the left. Process number 1, we're going to factor. Number 2, we're going to check to see if we have any holes in the graph. Again, you'll notice in our factoring, do we have anything that cancels? So nothing cancels, so we have no holes. Number 3, we're going to find the vertical asymptotes. Just just gonna call that VA. So what do we do to find the vertical asymptotes? We're gonna set the denominator equal to 0, so basically we're gonna say x plus 5 equals 0, x minus 1 equals 0. So we get x is negative 5, x is positive 1. So if we sketch in our vertical asymptotes, so there's our two vertical asymptotes on this one. We're now going to our horizontal. So on this one, as we're looking at the exponents, the top is x to the first and the bottom is x to the second. So in this case, n is smaller than m, so 1 is smaller than 2. So what's that tell us? What's our, yep, yep, so y equals 0. So again, that's the, it's kind of hard to see with the solid line already there. That's basically the x-axis is our horizontal asymptote. Again, if it has a horizontal, we know that there's no slant asymptote. Now, what it might be good for you to do is think about finding your intercepts on these, okay? In terms of where the graph crosses. And the thing I was trying to point out to you earlier is even though we've got a horizontal asymptote, in each of these three sections, the curve may cross over that asymptote. Does that make sense? So depending on the way the graph is set up there, in terms of, so if we're finding the Y-intercept, we're gonna put in 0 for x, so let's just do that here real quick. Y-intercept. If I put in 0 for x, and again, you can put it in either one of these. If I do just the first part here, I'm gonna get y equals, on the top there, I put in 0, so I get negative 4 on the top. On the bottom, I'm gonna get negative 5. So basically my y-intercept is 4/5. So 0 4/5, if I'm going up 1, it's gonna be right about at that point there, just below 1. If I'm finding the x-intercept, I'm gonna put in 0 for y. So I'm just going to use the factored one for that. So 0 equals x minus 4 over x plus 5 times x minus 1. I think of that just being 0 over 1. So basically you're going to get x minus 4 equals 0. So our x-intercept is going to be 4. So if I count over 1, 2, 3, 4, that's where it's gonna cross. Now this is the point I wanted to make. When you type this into your calculators, I don't know that it's gonna show that this particular graph is going through the asymptote right there, but notice that's a point on our graph. So in this right side of the curve, when you type this into your calculator, the curve's gonna look something like this. We're gonna approach this asymptote, it's gonna go through this point, it's gonna go this direction. Up here, we know it's going through this point here, and it's gonna approach this asymptote. It's kind of almost a U shape. Goes up, approaching this one. And then over in this section, we've got a curve that looks something like this. Again, you put that into your graphing calculator. Let's go ahead and do that. I'll put this up on the screen here so you can see what that looks like. When I type that in, here's kind of what that looks like. And I've got my windows set at -10 to 10, so maybe I make that -20, 20. Again, when you're making your graphs, you're gonna make your rough sketch of what they look like, and again, you can kind of see for whatever reason, in this middle part, you're not seeing the line going all the way up and approaching that. Is everybody following what I'm saying there on the graphing calculator? At -5, you know, I'm not sure why on the graph, but it shows it just kind of stopping there, and it's gonna keep approaching that asymptote. Does that make sense? Yeah. Yours doesn't do that. Let's see what you got. Well, so yours actually does show that it goes, it's good. Yeah.
Mine's curving a lot more than yours was.
What do you have your table or your window set at? Y scale to 215. See if that changes the way mine looks. Is everybody getting a graph that looks like what's up there on the screen? Is everybody good with that? If so, I'm gonna go ahead and move on. Everybody good with that? Okay, let's try and make it through here, maybe one more here, that's got a hole in it. I don't know how far we'll get here with this. Example 3. F of x equals x squared minus x all over x to the third minus x. first one we're gonna factor. Hopefully you can see on this, when we factor the top, we can take out an x. That's x minus 1. The bottom, again, we can also take out an x. That's x squared minus 1. And we know that x squared minus 1 can be factored again through x plus 1, x minus 1. Okay, so here's an example here where we're getting one that has holes. So you see that we've got some common factors on the top and the bottom. So we've got an x that's the same, so we can cancel out an x. And we've got an x minus 1 that's the same, we can cancel out the x minus 1s. So for each of those factors, that's gonna be how we determine the whole. So the x that's the same, set that equal to 0. And the x minus 1 that's the same, we set that equal to 0. So basically, we've got a whole at 0, and we've got a whole at positive 1. For our vertical asymptotes, we're gonna set the denominator equal to 0. Once we've done our canceling, we can go ahead and, we've only gotta worry about what's left. So, you know, at this point, we have f of x equals 1 over x plus 1. So for a vertical asymptote, x plus 1 equals 0. So x is gonna be negative 1 for that. Number 4, we go to our horizontal asymptote. Notice in this one, we've got an x to the second over an x to the third. So in this case, we know that n is smaller than m. So again, this is another one where, because n is smaller than m, we're just y equals 0.